Okay, so we're going to look at some codes for converting decimal to binary and vice versa. So in this exercise, we're creating several functions that will perform various conversions from binary to decimal. And first we'll convert integers. That's the easiest case. Then in subsequent videos we'll convert fixed point, and then finally floating point. All right, this very first video, we will create a function that converts the first n bits in an array of bits to a decimal integer. Okay, so this n bits, that's a variable name. So I'm going to take an array of bits and take the first n bits from there. Now notice I put this from numpy import star because I'm going to be making use of numpy arrays. And I don't want to use a prefix numpy or np. So if I import numpy as star, if I import star from numpy, then I can just use the numpy names without any prefix. All right? So first of all, my first command will be to define a function, and the name of the function is bin2decint with 2 arguments. Now why is it called bin2decint? Because I'm converting binary to a decimal integer. Now this function needs 2 arguments. First, it's the actual array of bits that contains the binary number as an array, and each entry in that array is going to be 1 or 0. And n bits is the number of bits to convert. All right? So let's go ahead and write that statement. Since we're defining a function, it's def, and the name of the function is bin2decint. So we write that here, bin2decint, and be careful about capitals. I'm using what's known as camel case, so my letters are lowercase unless I'm starting a new word, which I make it uppercase. All right. So here we have that, and then we have 2 input variables. The 2 inputs are bit array and n bits. As it says here, bit array is going to be the array of bits, and n bits is the number of bits to convert. All right. So I've finished my first statement. Now I haven't quite finished. See, that spider tells me there's a problem here. I need to put a colon at the end. All right, and that should take care of the problem. There it goes. All right, so I've taken care of this, so I'm going to delete this comment. All right. So let me go on. Now if I start here and press enter, you'll notice that it indents. All right, when it indents, then that means that I'm within a function, and all the statements that are indented will be inside the function. All right, so this is the next thing I need to do. Here, let me just go pull this back up here. Okay, I'll do that. Whoops, sorry. Okay. All right, so it says initialize decval to value 0, so we can add the contribution from each bit. All right. So let's go ahead and do that. It says I need to initialize decval. So decval is a variable. Okay. Now when it says initialize decval to 0, we just say decval equals 0. All right. And that should do it. Okay. And that's all we're asking for in that statement here. Let's go here. So now we need to start a for loop that examines each bit in bit array and adds its contribution to the decimal value. Let k be your loop variable. K runs from 0 to n bits in order to run through all the bits in the bit array. So the bit array is going to be something like this, 1, 1, 1, 0, 1. This is 5 bits down here, but they'll be contained in an array. But in order to go through make the conversion, we're going to have to go through every single entry in that array. So this would be the 0th entry, 1st entry, 2nd entry, 3rd entry, 4th entry. We're going to have to go all together through n bits entries. Right? So let's go after here, and this is going to be, I want to indent here, and it's going to be 4k in. Now how many entries do I want to go through? Well, I want to go through n bits entries. So we can do range of n bits. So that's going to mean k equals 0, 1, 2, 3, all the way up to n bits minus 1. And that will enable us to go through every bit in the array. All right, next. Since we're looking from highest to lowest, the previously added bits should be shifted left before the next bit is added. Okay, so we're going to add the contribution from each bit to decval, and decval will be our final value. Right. Now, the contents of the kth bit in bit array is bit array of k. Right. So here I'm going to have a decval is equal to a decval a plus, and let me just do this, it's not quite right, but I'll say this, a bit array of k. All right, now, notice what it says here. It says the previously added bits should be shifted left multiplied by 2 before the next bit is added. So I'm adding to decval the contribution from each bit, but every time I go to a new bit, I need to multiply my previous contribution by 2 because I'm shifting left. So I can do decval times 2. Of course, I could do 2 times decval. It's the same thing. All right. So here we have here. But you notice I made a mistake here. There's an X here. It says invalid syntax. I forgot the colon. Right. That spider's very nice that way. It tells me I make a mistake. And I'm going to have to indent twice here. All right. All right, so in fact, that's all I need to do because I'm going to go through the bits, add each contribution to the bit, and then when I'm finished, I will have my decimal value, and I can return that decimal value. So, so here I've got my return is going to be here, return the final value. Now, I'm not going in this far because that's not in the for loop, right? Everything here that's indented twice is in the for loop. So I want to back indent one, and I'll do return. And what I'm returning is decval. Okay. All right, so my code is actually finished. All I need to do is test it. And way to test it is, let's try an input. Here's an input 11101, and here I've worked it out. This first one corresponds to 16. This is 8. This is 4. This is 0 times 2. And then this is 1. And you add that up, that's 29. So I should be able to input a binary array of bits like this, and get out the value 29. Okay. So let me say, I'll call this value, or I'll say this, binary. That's going to be equal to, and it's going to be an array, so I have to say array. And then I'll just type in the bits just like this, but I have 11101. And then here I want to print. Now what I want to return is the, okay, let's see, I'll call this decimal, is equal to bin to dec int. I have to call the function of binary. Now, how many bits do I want to use? Well, here I've got 5 bits, so let's go ahead and say 5. Okay, and then I'll print decimal. Okay. And we'll see if this works out. If I'm correct, I should get out the value 29. So let's go ahead and save this. So let's call this something else. Well, we can just save it here. And then we'll go ahead and run it. Run by hitting F5. And you see here I got an output of 29. And down here you can see all the different variables that I got. Binary was my original array. 29 was my output. These are all constants that are defined in NumPy. Don't need to worry about those. But you can see that my conversion seems to be working. Now, to do a thorough test, you would do tests on more numbers. But for now, we'll stop here, and we have our completed code.